Session 12.5 Series and Parallel Capacitors. Here is a circuit that has n capacitors connected in series. When capacitors connected in series, the total capacitance have to be calculated using the reciprocal formula. That is 1 over Ct, where Ct is the total capacitance of the system, equals to 1 over C1 plus 1 over C2 plus 1 over C3 all the way to the last capacitor, or the nth capacitor, 1 over Cn. When we have two capacitors connected in series, we still can apply that shortcut formula, but for capacitors. That is, the total capacitance Ct equals to C1 times C2 divided by C1 plus C2. Is the formula that we use to find the total resistance in series. Here we have two capacitors, C1 and C2, connected in series. We want to find the total capacitance Ct of this circuit. Since they connected in series, we need to use the reciprocal formula. Since there are only two capacitors, we can just use the two terms of that general formula, which is 1 over Ct equals to 1 over C1 plus 1 over C2. Or we can use that shortcut formula, Ct equals to C1 times C2 divided by C1 plus C2. Plug in the numbers. It's 100 microfarad multiplies 120 microfarad divided by 120 microfarad plus 120 microfarad. Punch these numbers into calculator. I got 54.55 microfarad. Let's work on this example. For this circuit, 4 capacitors connected in series. These are C1, C2, C3, and C4. We want to find the total capacitance of this circuit. So first, write down the general formula, but we just need to keep 4 terms, since there are only 4 capacitors. The other version of this formula is this. Ct equals to 1 over the reciprocal sum. That is 1 over 100 microfarad plus 1 over 120 microfarad plus 240 microfarad plus 1 over 680 microfarad. If we enter these numbers into calculator, it is 41.72 microfarad. As you can see, here is a circuit that has two capacitors connected in parallel. That is, one side of the capacitor connects to one side of the second capacitor. The other side of the capacitor connects to the other side of the second capacitor. And both capacitors connected in parallel. This capacitor system connects to a voltage source called Vs. The next question is, what is the total capacitance for this capacitor system? When we connect capacitors in parallel, the total capacitance is just the sum of all the capacitors. So here, since we have only two capacitors, C1 and C2, the total capacitance, Ct, equals to C1 plus C2. I'm sure you have already noticed the formula we are using to find the total capacitance are opposite to the formulas that we use to find the total resistance. The formula that we use to find the total capacitance in series is the formula we use to find the total resistance in parallel. The formula we use to find the total capacitance in parallel is the formula that we use to find the total resistance in series. Let's work on this example. 5 capacitors C1, C2, C3, C4, and C5 connected in parallel. We want to find the total capacitance CT in this circuit. Since capacitors are connected in parallel, we can simply add them up. CT equals to C1 plus C2 plus C3 plus C4 and plus C5. Plug in the numbers. That is 100 microfarad plus 200 microfarad plus 100 microfarad plus 200 microfarad plus 470 microfarad. Once we add them up, that is 1070 microfarad. We can change these numbers to equivalent engineering notation. So at the end, it is 1.07 millifarad.